All right, so in this part of the PowerPoint presentation, what we're going to do is talk about ways of expressing concentration. You know in general what concentrations mean. If I say, oh, that tea is really strong or that coffee is really weak, in general, you know that means that it's a lower concentration. But of course, in chemistry, we need to have very particular um, calculations and amounts. And so concentration is based on the ratio of the amount of solute to the amount of solvent or a solution, depending on what unit you're using. And so, of course, we need much more precise measurements of concentration when we're talking about our reactions and things like that. All right, now we're going to actually, you've already talked about molarity back in the first semester, so that's one type of expressing concentration. And you may be familiar with other things that use percent concentrations. So the quantity of solute, solvent, or solution can be expressed in lots of different ways. So we know molarity is expressed in moles per liter, but we can express things in mass, whether it's the solute or the solvent or the solution. And so there's different units besides molarity that we're going to talk about here. All right, so let's just refresh. Molarity again is the number of moles per liter. How many moles in how many liters of solution? So this would be a moles per volume. And molarity is specifically liters. So if you're just trying to find the molarity of something, if you know the number of moles, so 0.2 moles of ethylene glycol, if it was dissolved in enough water to give you 2 liters of solution, then the molarity would be 0.2 moles divided by 2 liters, or 0.1 molar ethylene glycol. So remember, the capital M is molar, moles per liter, and we already did some of this back in chapter 4. A mass percent is another way when you don't want to have to worry about moles. And so a mass percentage is defined as the mass of the solute divided by the mass of the solution. So remember, the solution is the total of the solute plus the solvent. So the mass of the solution times 100%. So I think what's handy to remember is when you see something that's already in a percent, what that means is out of 100. So a 3.5% sodium chloride solution means that there's 3.5 grams of NaCl in 100 grams of solution, or the saltwater solution, the complete solution. So that's very helpful. You can also find it if you know how many grams and how many grams of solute and how many grams of solution you have. You can take one divided by the other and then multiply by 100%. But this is also handy to remember. If you already have it in percentage, it means that many grams per 100 grams of solution. Keep in mind, again, that because it's the solution, which is the solute plus the solvent, if you have 3.5 grams and 100 grams of solution, you have 96.5 grams of solvent, or if this is a water solution, for example. So you put 3.5 grams of the salt, 96.5 grams of the water, the solvent, and you'll have 100 grams total. So do be careful with that the solution is always made up of the solute plus the solvent. Okay. So how would you prepare 750 grams of an aqueous solution that is 2.5% sodium hydroxide by mass? So again, keep in mind that when you see a percent, what does that mean? That means 2.5 grams of NaOH for every 100 grams of solution. So the number of grams in 750 grams of solution times the 2.5%, 2.5 grams per 100 grams of solution, means that there are 19 grams of NaOH in 750 grams of solution. Another way you could do this is making a ratio. You could say, well, the 2.5% NaOH means 2.5 grams per 100 grams of solution. So how many grams is in 750? And you could cross multiply, and this would be the same result. So what does that mean? That means we want a total of 750 grams of solution. So we need to take 19 grams of NaOH, add 731 grams of water, and we'll get a total of 750 grams, and that solution will be 2.5%. 19 divided by 750 is 2.5%. What is the percent mass of glucose in a solution made by dissolving 163 grams of glucose in 850 grams water? So this one's much more straightforward. Percent is just grams of solute divided by grams of solution times 100%. So that would be 103 grams of glucose. Now just be really careful when you see the words. Are you talking about the solvent? Are you talking about the solution? In this case, the solute is the glucose. The solvent is the water. So the total of the solute and solvent is the solution. So you've got 163 grams of glucose divided by a total 850 grams of water plus 163 grams of glucose. So the total solution is 1,013 grams. So 163 divided by 1,013 times 100 gives me 16.1% solution. Don't forget to add the solute and the solvent. All right, so that brings us to a new unit that we will be using quite a bit in this chapter, and that's called molality rather than molarity. It's molality. Molality is given the symbol lowercase m, or kind of a cursive m. It's very important for this chapter, as we'll see later on, is because it doesn't change with changing temperatures. The concentration doesn't change. If you can imagine, we know that liquids tend to expand when they're heated, and so the concentration will change because the amount of liquid, the volume will change somewhat. So the concentration will change if you heat things up, especially if you make them very hot. But so if you're trying to do measurements that end up changing temperature, you can't really use molarity very effectively. Sometimes you can, but in this case, we're going to use this new unit called molality. And the definition of molality is the number of moles of solute divided by the kilograms of solvent. So again, be really careful with your definitions if you're talking about solute, solvent, or solution. So remember, molarity was moles per liter of solution. This is moles per kilogram of solvent. So just keep that in mind. If you keep that straight, you can usually do these problems fairly well. All right, so if you have 0.2 moles of ethylene glycol and it's dissolved in 2,000 grams of water, 2,000 grams is the same as 2 kilograms. So this would have a molality of 0.1, and you would say molal. So it's a 0.1 molal ethylene glycol. All right, what is the molality of a solution if you take 5.67 grams of glucose and you dissolve it in 25.2 grams of water? Well, what is molality? Molality is moles of solute, which is the glucose, per kilograms of solvent, which is the water. Okay, so since we need moles of solute, we're going to have to convert grams to moles. So 5.67 grams of glucose divided by the molecular weight, 180.2 grams per mole, gives me 0.0315 moles of glucose. All right, since the bottom you want to be kilograms of solvent, you want to convert 25.2 grams to kilograms. You just do that by moving the decimal over 3 places. So 25.2 grams of water is 0.0252 kilograms of water. So take the moles divided by the kilograms, and notice 25.2, if you move the decimal over, it's the same as 25.2 times 10 to the minus 3. It's just a different way of showing it. But if you just wrote 0.0252, it would be the same thing. And so this solution has a molality of 1.25 molal. All right, the final unit that we're going to talk about is called a mole fraction, and this has everything to do with moles. So a mole fraction of one component, and the mole fraction is given the little cursive X. The mole fraction of A, for example, is defined as the number of moles of the compound of interest. So if in this one doesn't really say solute or solvent, but it could be. So it could be the moles of the solute divided by the total moles of solution. It could be the moles of the solvent divided by the total moles of solution. So it's moles of one of the substances divided by the total moles. Okay. So for example, if we have 1 mole of ethylene glycol and we have 9 moles of water, what is the mole fraction? Well, 1 mole of ethylene glycol divided by a total of 10 moles would mean it has a mole fraction of 0.1. And mole fractions don't have a unit because moles cancel out. What would the mole fraction of water be? Well, in this case, the mole fraction of water would be 9 divided by the total 10, or 0.9. And notice that the mole fraction of all the compounds together should add up to 1. So the mole fraction of ethylene glycol is 0.1, the mole fraction of water is 0.9, the total will be 1.0. So one of the things that you're going to have to do in this chapter is to be able to convert from molality to molarity, or molality to mole fraction, or mole fraction to molarity, convert between the units. And as long as you know the definitions of your different concentrations, you should be fine. So it can get a little bit confusing, but again, I highly recommend that you really learn by heart your definitions. So, for example, molal is moles of solute divided by kilograms of solvent. Molarity is moles of solute divided by liters of solution. Keep all that in mind. So, let's say we want to convert a 1.2 molal solution of glucose to mole fraction. We want to know what is the mole fraction of each of the components. So there's glucose in water. How do I know it's water? Because it's an aqueous solution. That means I'm dissolving glucose in water. So what are the mole fractions of the glucose? What is the mole fraction of the water? Well, you might look at that and say, I have no idea. Well, 1.2 molal, the little m, don't forget what's involved with that. What does that mean? It means there's 1.2 moles of glucose for every kilogram of water. The kilograms of solvent. The water is solvent, glucose is a solute. So the first thing we know is that we have 1.2 moles of glucose. Well, now think about what is mole fraction. Mole fraction is moles of one component divided by the total moles. So if we know the moles of glucose, but we don't know the moles of water. So we know that 1.2 molal means there's 1.2 moles of glucose in 1 kilogram of water. So if we convert 1 kilogram of water to moles of water, then we have the moles of everything. So first, if we take 1,000 grams, or a kilogram, 1,000 grams divided by the molecular weight, and we find out that we have 55.6 moles of water in this solution. So then, to find the mole fraction of glucose, it's just the moles of glucose, 1.2, divided by the total moles, in this case 1.2 plus 55.6. And the answer is 0.0211. So the mole fraction of glucose is 0.0211. What is the mole fraction of water? Well, it's the moles of water divided by the total moles, which is 0.979. Now, these are significant figure-wise, but notice that if you add 0.979 plus 0.021, you'll get a total of 1. So all the mole fraction has to add up to 1. All right, so here's an example. What is the molality and mole fraction of a solution made with 5.05 grams of naphthalene dissolved in 65.9 grams of benzene? The first thing you want to do is identify your solute and solvent. So naphthalene is the solute and benzene is the solvent. All right, then we want to use our definition. Molality is moles of solute divided by kilograms of solvent. Okay, so we need to convert grams of naphthalene to moles of naphthalene, and we have to convert grams of benzene to kilograms of benzene. So let's do that. All right, so 65.9 grams of benzene is 0.0659 kilograms. 5.05 grams of naphthalene divided by the molecular weight gives you moles of naphthalene. And so molality is just the moles divided by the kilograms, which is 0.598 molal. All right, so let's keep going and do the mole fraction. Okay, so now to do the mole fraction, the mole fraction of the naphthalene is the moles of naphthalene divided by the total moles, naphthalene and benzene. And we found on the last slide that the moles of naphthalene is 0.0394. We had already figured that out. So now we need the moles of benzene. The moles of benzene, we take the grams of benzene divided by the molecular weight of benzene, and it's 0.844 moles. So let's see, the mole fraction of benzene is the moles of benzene divided by the total moles again. So the moles of naphthalene, 0.0394 divided by the total moles, 0.0394 plus 0.844 will give us a mole fraction of 0.045. And then the mole fraction of benzene, which is the moles of benzene divided by the total moles, will give us a mole fraction of 0.955. And again, since there's only two components, the mole fractions should equal 1. All right, so this is probably the most complicated problem. How can we convert from molality to molarity? Or actually, we'll see another example. How do you convert from molarity to molality? So we need to be able to go back and forth. Do note that because we're converting from kilograms of solvent to liters of solution, we need to know the density of the solution. So that will always have to be given to you in this kind of problem. All right, so convert 10.7 molal of ethylene glycol in water, an aqueous ethylene glycol solution. Convert 10.7 molal to units of molarity, and notice that the density is given to you. Again, density will need to be given to you, and it will be given in the problem. All right, so keep your definitions in mind. What is molality? Molality means moles of solute divided by kilograms of solvent. Or in this case, be more specific, moles of ethylene glycol divided by kilograms of water. So in this case, the fact that we know it's 10.7 molal means we have 10.7 moles for every 1 kilogram of water. Molarity then is what we're trying to get to. Molarity is moles of ethylene glycol, which we already know, divided by liters of solution. So somehow we have to convert kilograms of water to liters of solution. And remember, solution has both water and ethylene glycol. So that's where the density comes in to play. But don't forget that the solution is the combination of the two. So we have two things to do. We have to find the total mass of the solution, and then we have to convert that to liters of solution. All right, so what do we know? A 10.7 molal solution means we have 10.7 moles of ethylene glycol for every 1 kilogram of water. Okay, so maybe we don't have a whole kilogram of this solution, but the ratio will always be true no matter what. So that's the important thing. So what do we need to find? Somehow we have to find the kilograms. Let's see, we have to convert the kilograms of water to the liters of solution. So we need the volume of the solution. How can we do this? Well, first we have to find the total mass of the solution. If we know the total mass of the solution, we can convert that to volume using the density. So we need the total mass of the solution. But before we can do that, we have to find the total mass, we have to add the mass of the solute and the mass of the solvent. So right now we don't really know the mass of the solute. We know the moles of the solute. We do know the mass of the solvent, however. So if we add the mass of the solute plus the mass of the solvent, we'll get the mass of the solution. And then we can convert the mass of the solution to the liters of solution. All right, so let's see how we do that. All right, what's the weight of the solute? 10.7 moles. We know the molecular weight, so we can convert to 664 grams. So if we have 1 kilogram of of water, of our solvent, and we have 10.7 moles of our solute, that also means we have 664 grams of our solute in this solution. All right, so that's the mass of the solute. The mass of the solution is 1,000 grams of water plus 664 grams of ethylene glycol. So that means the total mass of solution is 1,664 grams. So that means we can convert grams to milliliters using the density. The volume is 1664 grams. We're going to divide by the density, 1.05 grams per mil. The grams cancel, so we have 1,585 milliliters of solution, which is the same as 1.585 liters. Doesn't really matter to convert, but since molarity is in liters, we need to convert to liters. All right, so now we know the volume of the solution. So to find molarity, all we need is moles of solute, which we already knew from the beginning was 10.7, divided by the volume of the solution. Remember, solution's both solute and solvent. And so this, the molarity of the solution is 6.75 moles per liter. And that's how you convert from molality to molarity. So keep in mind two things. We need the total mass of the solution. We know the mass of the solvent, so we have to find the mass of the solute. Add them together, we get the total mass of the solution, and then we can convert that to volume of solution. So what if we're trying to convert from molarity to molality? We're going to do what we just saw, but in reverse. So let's say we have a solution of toluene in benzene. And it has a molarity of 0.21 moles per liter. Again, we need to know the density of the solution. So what is the molality? So again, keep your definitions in mind because this is moles per liter of solution. And somehow we have to convert that to grams of solution, and then we have to subtract out the grams of the solute because we only want to know the grams or the kilograms of the solvent for molality. So again, keep your definitions handy. So again, a 0.21 molar solution means we have 0.21 moles of toluene for a liter of solution. And again, the solution would be toluene plus benzene. So we have to somehow convert 1 liter of solution to the mass of solvent alone. So the first thing we can do is convert the volume of solution to the mass of solution using the density. So 1 liter of solution, which is 1,000 milliliters, times the density in grams per milliliter means that if we have 1 liter of solution, we have 876 grams of solution. Okay, but remember that solution and not just solvent. So somehow we have to subtract off the mass of the solvent. Or I'm sorry, we have to subtract off the mass of the solute to find the mass of the solvent. All right, so if we subtract the mass of the solute from the mass of the solution, we will find the mass of the solvent. So let's keep that in mind. So we know the mass, 876 grams of toluene and benzene together. So if we subtract the mass of the toluene, then we'll have the mass of just the benzene. Well, we don't know either of those right now. So, but we do know the moles of toluene. We can convert 0.21 moles to grams. So 0.21 moles of toluene times the molecular weight of toluene tells me that out of this total 876 grams of solution, 19 grams is toluene because it's 0.21 moles. Right, so now if we subtract that, 876 minus 19 means that the rest of it, 857 grams, is benzene or solvent. Convert that to kilograms because of course our definition is moles per kilogram solvent. Okay, so now we can just easily find the molality because it's moles of solute, which we know is 0.21, divided by kilograms of solvent, because we've already subtracted off the solute, 0.857 kilograms, so it's 0.25 molal. Notice that in this case, the molarity and molality are pretty similar to each other, so it sort of depends on what the compounds are and what the density is to find out. But remember, in that last example, it was like the molality was 10.7 and the molarity was 6.8. So it can be really different, or it can be similar. So you always have to have the right units. All right, so I made this little chart, and some of you may not like it, and if not, then don't use it. But this is sort of the step-by-step. If you know the molality, how do you get to molarity? If you know the molarity, how do you get to molality? Well, notice that in each case, you know the moles, because that's the numerator, the moles of solute. So let's say you starting with molality and you want to find molarity. So if you follow the process, with molality, we know the moles of the solute and we know the mass of the solvent, because molality is moles per kilogram of solvent. So you actually have to follow the mass of the solvent. You're going to have to add together. Now, in both cases, we know the mass of solute. The moles of solute, no matter if you're talking molality or molarity. So you can always convert moles of solute to mass of solute. So to go from molality to molarity, you're going to have to add the solvent plus the solute to get the mass of the solution. Then you can convert mass of solution using density to volume of solution, and you have molarity. If you're wanting to go the opposite way from molarity to molality, you're going to have to work backwards. So first, you know moles and you know volume of solution. So convert from volume of solution to mass of solution using the density. Again, you're going to have to convert moles of solute to mass of solute, and then this time you're going to subtract. So going from purple to green, follow the arrow and subtract. So mass of solution minus the mass of the solute will give you the mass of the solvent. And so then molality is moles divided by kilograms of solvent. So this is sort of the process. If this chart helps you to follow the process, by all means use it.